Hello everyone and welcome to the 11th lecture in our CS2100. So in the next several lectures, we'll introduce functions and relations. We'll talk about their properties, and we'll also show how to do simple proofs about them. So let's get started. So first, let's introduce functions. I'm sure you've heard of functions before. You probably wrote functions in your programming classes. In CS2100, we'll focus on functions from the perspective of mathematics. So what is a function? Well, given two sets, A and B, a function from A to B relates each input element, A element of A, to an element B element of B, and we write it as this. So as this little diagram here illustrates, F takes A and it maps it into B. So this set of inputs A is typically called domain, and the set from which the outputs are taken, this set B, is called the codomain. The rule that defines how the output is related to the input is frequently designated by a letter. So in our case, we used F. We can also write it in terms of both the elements of A and the rule. So for all A element of A, there exists B element of B such that F of A is equal to B. And note here that each element of A has exactly one output, and we'll talk more about that. So a function is defined using three components: domain, codomain, and this rule that we already talked about that we usually denote using a letter. The set F of A, which is equal to F mapped to A, where L is an element of A, is called the image or the range of F. And note that this image or range is a subset of B. So basically, the codomain includes all elements that F can map to and more. And just the set of elements that F can map to from A is called image or range. And I'll illustrate that in an example later on. Okay, so here are some examples. So we have a function F here that is specified as F of X is equal to X squared. So this specifies the mapping. We have the domain that is equal to Z. Now the question is, what is the codomain? Codomain in this case is equal to Z as well. And note that codomain is a superset of the image. Of course, there are integers to which F will not map to. For example, 3 is an example of such an integer, but 3 still belongs to the codomain. So make sure that you can distinguish between the image of the function, which would be all integers that are a square of some other integer, such as 1, 4, 9, 16, 25, and so on. And there is also the domain, which is a superset of this set, and the domain are all integers. Another example function that includes people. So domain are students taking CS 2100 this semester. Codomain are all the days of the year. And then the rule would be we map each student to their birthday. This is a function, for example, because we cannot map the same student to 2 birthdays. Another example that uses Cartesian product, domain is z times z plus. The rule is that f of a comma b is equal to a to the power b. So codomain is also z. And so this is just another example of a function. Okay. So how do we describe this rule that defines the function? There are a couple of different ways to do it. So let's see how we could describe the rule for function f, which maps this set of numbers into the set of natural numbers n. So we could use an English sentence, such as to each number in the domain, associate the square of the number. Then we could use a formula, which is what we did in the previous slides, and that's the most common way to define the rule. So f of x is equal to x squared. Another way of doing it is to list all possible combinations of inputs and outputs. So in this case, f would consist of the order pairs of numbers 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Of course, this is practical only for small domains. If your domain is, for example, the set of all integers, there is no way you can list all possible combinations of inputs and outputs. So the thing to remember here that using algebraic formula is the most common way to specify a function. Okay, so another way to specify a function is using so-called arrow diagrams. So here we use an arrow from each input value to its associated output value. So if our domain is this set 1, 2, 3, 4, 5, codomain is a set of natural numbers, and the function is defined as f of a is equal to a minus 3 squared, then this here below is the arrow diagram that specifies this function. And the same as when we specify functions with pairs, input-output pairs, drawing arrow diagrams is possible only if the domain is small. If the domain is very large, we cannot draw such a diagram. And so we use these diagrams to illustrate certain concepts about functions and also definitions of functions, inverses, and so on. So you should learn how to draw them. So let's look at one example problem that requires from us to draw an arrow diagram. So we have this set X that contains elements A, B, C. And we define the function d that maps the elements of the power set of x into 0, 1, 2, 3. And the rule is that d of a is equal to n of a. So we are mapping each element of the power set into its size. So let's make a two-set arrow diagram of this function. So first we have to list all the elements of the domain, meaning this power set. So we have an empty set. We have a set containing just A, containing just B, and containing just C. Then we have all possible sets of pairs. So we have A, B, we have A, C, and we have B, C. And then we have the whole set, A, B, C. So this whole thing is our domain. And then the codomain is just 0, 1, 2, 3. So there's the codomain, and now we have to connect them. So remember the rule, we map each of these sets to its size. So the size of empty set is 0, the size of this is 1, this is 1, this is 1, then these ones are 2, and the last one is 3. And that's it. This is our error diagram for this example problem. So you should make sure that you know how to draw error diagrams. Okay, so we introduced functions. Next, I'll introduce another concept called relations. And we'll start with binary relations. So a binary relation, or just a relation, consists of 3 components: domain A, codomain B, and a rule which is a subset of Cartesian product of A and B. So here's an example, relation R1, where the domain is set S of all students taking CS 2100 this semester. Codomain is set C of all classes being offered at the U this semester. And the rule is that the pair SC belongs to the relation R1 if student S is taking class C this semester. Okay. Here is an arrow diagram illustrating relations. So we have a set X that contains ABC, and we define the relation R that maps the power set of X into X, with the rule that A comma X belongs to R if X is an element of A. And you can see these mappings here. So everything that contains A is mapped to A, everything that contains B is mapped to B, and so on. So one thing to note here is that there are elements in the domain. For example, this set AB that is being mapped to 2 elements in the codomain. And the last set ABC is mapped to 3 elements in the codomain. So that's one distinction that relations have when compared to functions. You can map the same element from the domain into multiple elements in the codomain. So functions are, because of that, a special case of relations. So functions are relations where there is this additional constraint that every element of the domain can be mapped only to just a single element in the codomain. Then graphs are relations as well on the Cartesian product of the set of vertices with itself. And edges are the members of this Cartesian product. So you can describe a graph easily using a relation. So I already mentioned this. We have a function f that maps elements from A into elements from B. That's equivalent to the relation f that is a subset of A times B. So a function f from A to B is a binary relation with the property that for every x element of A, there is exactly one element y of B for which x comma y is an element of f. And here this is written in a more formal way. For example, if our domain is 1 to 3 and the function a goes from that to a squared, then we can define this relation by specifying it as this set of pairs And so this function is also a relation as every other function. Now, is the relation a function? I already kind of hinted at that by giving that example of students and courses. So that relation is not a function, because for a typical student in CS2100, there is more than one other course that the student is taking. So there are many students that will be mapped to multiple courses, and that violates the requirement for relation to be a function. Then another example, domain is 1, 2, 3, 4, 5. Codomain is the same, and the rule is xy is an element of R2 if x minus y is even. So is that relation a function? Not quite, because both 1, 3 and 1, 5 belong to R2, and so that means that 1 is mapped to 2 different elements in the codomain. Let's look at R3. Domain is N, codomain is Z. Rule is that the relation R3 is equal to a set of pairs x, y such that x is equal to y squared. So is this relation a function? So the answer is no, because there is no element y in the codomain for domain element x is equal to 2. And on top of that, 1, 1 and 1, minus 1 are both in this relation, and therefore 1 is mapped to 2 elements. So again, this signifies why this is not a function. And about the first part of this point, function has to map all elements from the domain into something. That's not true for relations. Another couple of examples. This time we're using arrow diagrams. So we have domain that is the set A containing 1, 2, 3, 4. The codomain is set B containing 1, 2, 3. For each of these arrow diagrams that show relations, we want to figure out whether it's a function or not. Okay, so is R4 a function? The answer is yes. So note that it's perfectly fine for functions to map 2 different elements of the domain into the same element in the codomain. So that's okay for functions. Is R5 a function? It's not, because it's not mapping 1 to anything. So relations have to map every element from domain into something. Sorry, functions have to map every element from domain into something. Is R6 a function? So yes, it is. It's mapping all elements into something. R7 is not, because it's mapping this element 3 into 2 different elements in the codomain, and that is not allowed in functions.